So welcome students, welcome to all of you in this video lectures. Here I am going to continue the chapter 5. The name of the chapter is Continuity and Differentiability. So students, in this video lectures I am going to explain you the derivative of parametric forms, functions in parametric forms, and the concept of second derivative. So students, what is the concept of parametric form? The parametric form is suppose x and y are two functions of variable t. X is a function of t and y is a function of t. So first we have to differentiate x with respect to t. So we'll get dx by dt, and then we have to differentiate y with respect to t, then we'll get dx by dt. So after that we can find out dy by dx easily by doing dy by dt divided by dx by dt. So which will get dy by dx equal to f dash g dash t by f dash t, which is the derivative of y with respect to t, provided f dash t not equal to 0. So I hope students you understood the concept of parametric forms and the technique of finding its derivative. So students, next I'll explain you what is the concept of second derivative. Second derivative is very simple. If you differentiate a function two times, then you will get the second order derivative. For example, suppose y is a function of x, y equal to fx. When you differentiate y with respect to x, so we'll get dy by dx, so we'll get f dash x. Now if you differentiate again with respect to x, we'll get ddx of dy by dx equal to f double dash t. F double dash t is nothing but the second derivative, so it is d2y dx2. d2y dx2 is nothing but f double dash x, and d2y dx2 is known as the second derivative of y with respect to x, and it is also said d2y or y double dash or y2. These all are the symbol of writing second derivative of a function y equal to fx. So I hope students all of you understood the concept of technique of second derivative. Now I'll discuss some question related to that concept. First question you can see in the screen: x equal to a cos theta and y equal to b cos theta. So students, we have to find out dy by dx. So it is a parametric form. So first we have to differentiate x with respect to theta. When we differentiate x with respect to theta, we'll get dx dt. So dx dt is d theta of a cos theta. So a is constant here. So a is constant. So d theta of cos theta is minus sin theta. So it get minus a sin theta. Now when you differentiate y with respect to x, so theta, so dy d theta of b cos theta. So b is constant, comes out from the derivative. So d theta of cos theta is minus sin theta. So answer is minus b sin theta. Now substituting the values in dy by dx, so we get dy by dx. You can see that dy by dx equal to dy by d theta divided by dx by d theta. Substituting the values, minus b sin theta by minus a sin theta. So minus get cancelled, sin theta get cancelled. Answer is b by a. So I hope students you understood these questions. Next questions you can see in the screen. Question is x equal to cos theta. X equal to cos theta minus cos 2 theta, and y equal to sin theta minus sin 2 theta. So students, first of all we have to differentiate x with respect to theta. So we will get dx by d theta. So d theta of cos theta minus cos 2 theta. So d theta of cos theta minus d theta of cos 2 theta. So d theta of cos theta is nothing but minus sin theta, and d theta of cos 2 theta is minus 2 sin 2 theta. I hope all of you know this. So it is 2 sin 2 theta, because minus minus get cancelled and it will be plus, and 2 minus minus plus, so it is 2 sin 2 theta minus sin theta. It is the answer for dx by d theta. Next, when you do dy by d theta, d theta of sin theta minus sin 2 theta, So d d theta of sin theta minus d d theta of sin 2 theta. So sin theta is cos theta minus d d theta of sin 2 theta is 2 cos 2 theta. Now putting the value of now dy by dx is dy by d theta divided by dx by d theta. Now putting the value of dy by d theta and dx by d theta, we got the answer. Required answer is cos theta minus 2 cos 2 theta divided by 2 sin 2 theta minus sin theta. So students, I hope all of you understood this concept. Okay, so next it is the next question. You can see in the screen similar type of questions. X is given a cos theta plus theta sin theta, and y is given a sin theta minus theta cos theta. So students, when you differentiate x with respect to theta, we got dx by d theta. A is constant, so comes out from the derivative. D d theta of cos theta plus d d theta of theta sin theta, and d d theta of cos theta is minus sin theta, and d d theta of theta cos sin theta we have to do u into v rule. So we have got theta is first function, theta into d d theta of sin theta plus sin theta into d d theta of theta. So in this function we got the answer is a into minus sin theta plus theta cos theta plus sin theta get cancelled, and answer is a theta cos theta. Now when you do dy by d theta, a into d d theta of sin theta minus d d theta of theta cos theta. Similarly, if you differentiate, we will get the value of dy by d theta is a theta sin theta, because yes, cos theta will get cancelled, and the result will be a theta sin theta. Now ultimately the value of dy by d theta and dx by d theta we have to substitute like this: dy by dx equal to dy by d theta by dx by d theta, and putting the values a theta sin theta divided by a theta cos theta. Here you can see that a theta get cancelled and sin theta by cos theta, the answer is tan theta. So I hope students understood this technique. The next next we'll do one concept of second derivative. You can see that y equal to cos inverse x, and we have to find d2y dx2 in terms of y alone. So students, the question is given y equal to cos inverse x. So let us differentiate first. So when you differentiate y equal to cos inverse x, we will get dy by dx. ddx of cos inverse x is minus 1 by root over 1 minus x square. Now we can write this function as minus into 1 minus x square to the power minus 3 by minus half. Okay. Now again we have differentiate this with respect to x, d2y by dx2, ddx of minus 1 minus x square to the power minus half, and this function acts like x to the power n, where n is minus half. So we can apply nx to the power n minus 1, where x is 1 minus x square. So minus into minus half, 1 minus x square to the power minus half minus 1, which become minus 3 by 2, and again ddx of 1 minus x square. So ultimately ddx of 1 minus x square is minus 2x. The 2 will get cancelled. So we have got it minus x divided by root over 1 minus x square to the power 3. Now putting the value of we have taken y equal to x cos inverse x. So from there we can find out the value of x is cos y. So in the result of d2y dx2, substituting the value of x equal to cos y, you can see that in equation number 1, when you substitute x equal to cos y, what you will get? d2y dx2 equal to minus of cos y divided by root over under root 1 minus cos square y whole cube. So student, this is the answer of second derivative of the given function. So I hope all of you understood. This is one question, one proving. One function is given, a equal to e to the power mx plus b e to the power nx. We have to prove that d2y dx2 minus m plus n dy dx plus mn y. The students, first of all we have to differentiate the given function with respect to x. So dy by dx equal to d dx of a e to the power mx plus b e to the power nx, where a is constant, b is constant. So a comes out from the derivative. We can write a into derivative of e to the power mx plus b into derivative of e to the power nx. So students, here a is constant, so derivative of e to the power mx is e to the power mx into derivative of mx plus b into derivative of e to the power nx is e to the power nx into derivative of nx. So it is am, derivative of mx is m only, am e to the power mx plus bn e to the power nx. Now when we differentiate again, so d2y dx2 ddx of dy dx we have am e to the power mx plus bn e to the power nx. So here you can see that am is constant, so am comes out from derivative, am ddx of e to the power mx plus bn ddx of e to the power nx. So am e to the power mx ddx of e to the power mx is, again we are using the same, e to the power mx into ddx of mx plus bn into ddx of e to the power nx, e to the power nx into ddx of nx. So students, ddx of mx, again we have got m, so you can see that am into m, we have am square e to the power mx plus bn into n, bn square e to the power mx. Now we will take the right hand side, we will take the proving part, substituting the values of d2y dx2 minus m plus n dy by dx plus mn into y. Substituting these values, am square e to the power mx plus bn square e to the power nx minus m plus n, am plus n, am e to the power mx plus bn e to the power nx plus mn into a e to the power mx plus b e to the power nx. Now when we remove the bracket and simplify, you can see that all the like terms get cancelled. Am square e to the power mx and one terms is there, am square, so 1 plus minus get cancelled. Similarly bn square e to the power nx, there are two terms, one is plus, one is minus, get cancelled. bmn e to the power nx, also two terms, one is plus, minus, cancelled, and all the terms like this get cancelled, and we have got the answer is 0, and hence proved. So students, I hope all of you understood my today's lecture, where I have explained the concept of parametric form and second derivative. If you have any question, any doubt, you can contact me. Thank you very much.